After rectifying and locating plats, the most important base layer of your parcel data set is going to be your right-of-ways. The right-of-ways are where the parcels are most often mapped from, where you would start. That's your anchor in most cases. And it gives you a nice aesthetic map. It gives you a nice looking, clean tax map like you're used to seeing with your paper maps. In order to do this, it is very important that you digitize a new centerline layer. Now, the new layer that is going to be created is going to have to use geometric curves and not straight line curves. And that in itself is the reason that we create this new centerline layer as opposed to using an existing one or a 911 layer. And that's not saying anything's wrong with a 911 centerline layer or any other centerline layer, but more often than not, and I'll say 99 to 99.9% of the time, an older centerline layer or 911 layer, the curves are going to be digitized using straight lines. So in the state of West Virginia, there are no straight roads. You've got all curves. So a straight line curve, while you look at it from a 911 application, this is just fine. There's no problem with it. And they can look good. They can follow the center line very closely. But what happens is when you get to building out your right-of-way network and you're buffering these center lines, if there's a straight line curve, you zoom in on this thing, you see a little jagged edge. When you buffer this center line 20, 30, 40, 50, 60 feet, those jagged edges are amplified tremendously. And so the worse the geometry of that center line is, the worse you're going to end up with messy right-of-way network. You're not going to have smooth curves, and it's going to look bad. So that's the reason for taking the time to recreate a centerline network. And your 911 centerlines are very important in doing so because that's your reference layer. That's what you're using as a reference to attack these new centerlines that you created. So again, I'm not bashing any other centerline layers. It's just not designed for this type of mapping application. So that leading into buffering of your right-of-ways. Like I mentioned, this is a very, very important part of your mapping process. The right-of-way network is that's your base. There is not necessarily a standard right-of-way width used throughout the state for county routes, state routes, federal routes, but there are some common widths. Your 30 foot for your county routes, your 40 foot for your state routes, 50 and 60 on up for federal and for most of the turnpikes, and you're going to have irregular right-of-ways in there as well. But we use those common widths as our starting point. So you're going to use your rectified tax maps as you're building this network. Start with your common width and you buffer. You find that this is a county route, you buffer 30 feet, and you are way inside of where this rectified tax map is illustrated your right-of-way goes. Or you're way outside, or wherever it may be. If it's not matching, then you would scale the width from the tax maps, and that's just simply measuring the distance from one side of this right-of-way tax map to the other. Now, since you've got a rectified map that's hopefully not warped in any way, you're going to get a fairly accurate width as long as that width was accurate drawn tax map. And you're going to take a couple of these. You're not going to just take one and say, okay, it's 40 feet here. Because you will find some times that it might be an odd width, like 45 feet, or even getting into some town areas, you may have 17 and a half or 12 and a half. So you want to take a couple of samples along the right of way that's not matching that common width, and then get your width from that scale tax map. Now, it's important to mention that while in the rural areas, we're going to be buffering the right-of-ways from that digitized, that nice new center line that's now following the road network. However, when you get into town or city areas, or anywhere that has a block-style right-of-way network, we've got nice even corners, we've got square blocks. it's important to remember to keep that nice square geometry in your new data. You want to. Now, sometimes your road on your orthos here may not fall. These intersections may not be dead even and nice and curvy with each other like the right-of-ways that are illustrated on your tax map. But you want to keep your right-of-ways in that same fashion. So sometimes what you end up doing, if you've got 4 blocks going across each other, and these are all nice even corners, and your roads, these roads may have been built at different times and they may shift a little bit. You want to find a common line between all of them. You want to find a common line that's going to satisfy the relative center line of this section of blocks, and we're going to use that to buffer your right-of-way. And when you do that, and you cut out your intersections for these different right-of-ways, then you, in the end, you replicate that tax map geometry of these nice even blocks, even though on the aerials it's going to be slightly different. If you go with just the aerials, you're going to end up with jagged blocks, and you end up with something that you're going to have to clean up because the network is not going to match the original tax maps. DOT right-of-way plans. These can be very useful. We've usually used these in what I would call trouble areas. Maybe turnpikes or federal highways or somewhere that there are a lot of irregular right-of-way changes. And this doesn't mean that it's just changing widths, but many of you have probably seen when some federal turnpike right-of-ways are going in and out and all over the place. There's been a lot of different dedications and it can get really complicated. So when you've got a situation like this, you've got 2 choices. You can, if your tax maps are good, you're going to want to create this irregular network from your tax maps. If you have a big mess on your hand, or you want to go to the next level, you can go to the DOT and get the actual right-of-way plans. These are very useful. It's a little bit more time-consuming to put these in because you're going to need to use the right-of-way stations and the widths from those stations. So we would rectify these similar to how you would a tax map, and then you're going to also place your stations, these stations that are 100 feet apart, or typically 100 plus or minus where they decided to place that station on the engineering.
Yeah, in addition to that, in some cases, old or historical maps are helpful because DOT usually, when they go in and buy right-of-way or interstates, for example, all through Raleigh County, what we have is that they bought the whole parcel instead of just the right-of-way that they needed. So older maps can actually help you with those jagged edges on the right-of-ways because it's not usually just the interstate plus so many feet. In some cases, they have those jagged edges. So historical maps also are also helpful.
Correct.
And the DOT, the regional offices have always been good to let us come in. They look at us a little strange, like, you want to do what? And really all we need is, and the biggest problem we have with them is they only open between certain hours. So we have to work limited hours. We can't work at night and that sort of thing in there because they won't let us have it. Although I will say the guy in Lewisburg gave me a key to the building and said, go for it. Because he got tired of seeing it. But on a lot of these old turnpikes, and y'all have a situation here in West Virginia, road embankments and cuts. Every time you hit a major embankment, a major cut, you can rest assured the right-of-way is not 50 feet anymore because they've had to do things. Y'all have a lot of that. So what we find on a lot of, and you don't necessarily show that on a 30-foot right-of-way on a county road where there's a 15-foot cut. But on these major highways, you do show it. So your right-of-way is to get. And again, keep in mind, like Trey said, you're mapping the parcels from the right-of-ways back. You start out with a bad right-of-way, you're already behind the 8 ball in terms of the quality of what you're doing. So, yeah, I think.